So to find the measure of angle A, we would have to use, if we're only given two sides, we would, in this particular problem, we would have to use sine. Sine of angle A is equal to opposite over hypotenuse. So in this equation, we have to isolate the variable, which is A, angle A. And we cannot divide both sides by sine because sine is not being multiplied. Sine is a function. It's doing something. It's not multiplying by angle A. It's a function. So in order to get rid of sine, we have to do the inverse of sine. Anytime you try to get rid of something in an equation, you do the inverse. Because the inverse, like if you're adding 3, you subtract 3. If you're multiplying by 3, you divide by 3. If you're dividing by 5, you have to multiply by 5. Those are inverses. But if you're squaring, or if you have the square root, you would square it. Or if you're squaring, you would take the square root, right? So those are inverses. Well, the inverse of sine is the inverse of sine. So what you would do, and you don't have to show this, I'm going to put it in blue. This is not something we'll show every time, is you take the inverse sine of both sides. When you take the inverse sine of the sine of something, it gets rid of that. This cancels, and you end up with angle A on the left-hand side. And then you're taking the inverse sine on the right-hand side. So that's how you can, it's the only way you can take the trig function away from the angle measure. And there's a button for that. So it's second sine. Second sine, second cosine, second tangent will give you all of your inverse functions. So second sine, 1 divided by 2 is 30 degrees. And we can use cosine of angle B is equal to 1 over 2 to find the other angle. But what is the other angle? 60. We don't have to do that. Why do that whenever we can just subtract it from 90? What is the measure of this side? Do we have to use Pythagorean's theorem to find the measure of this side? What is it?
1 square, 1/3.
You're right. It is the square root of 3. 1 times the square root of 3 is the square root of 3. Now, if you had this problem on a test or something, you wouldn't even have to use trig. The converse of a special right triangle works. If you have a right triangle and 2 of the 3 sides of a special right triangle, then you can see that this would be the square root of 3 without knowing the angle measures. It makes it a 30, 60, 90. Okay, so on the next slide, we have the same thing. Hold on, don't write any of this down. I don't think I'm going to use this one because I went ahead and did what I wanted to do on the other one, so it would be redundant to do that. Okay, so let's do this one. One thing I did forget to point out was the definition of solving a right triangle, what that means, which was on the first slide. To solve a right triangle, or to solve a triangle, is to find any missing angles or measures. Angle measures or side lengths. So, for example, this triangle ABC, we have one side missing, and we have 2 angles missing. We already know the measure of one angle, and that's 90 degrees. So we've got to find this side and these 2 angles. The hardest part of this section is you have choices, lots of choices. So we can, you want to use the easiest choice, really. And on this triangle, how do we find that third side? Do we know? Without doing any work? Okay. So here's one thing that would be helpful to make sure you don't forget anything. Go ahead and put, if you're solving a triangle, go ahead and label what you're looking for. So AB is equal to, angle A is equal to, and then angle C. Because sometimes you can get caught up in your work and forget part of your triangle. So we need to make sure we answer all 3 things that are missing there. So Let's see, what are the triples? Let's see if we have a triple. 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41, 11, 60, 61. If you'll write them over and over and over again, it will help. You can still do the flashcards, but for me it's easier. Anytime I think of triples, I write them down. So what is AB? 7. Okay, if I want to find the measure of angle A, do I have to use tangent? Can I use cosine? Can I use sine? So that's what I'm talking about here. When you have all three sides, you can use any trig function you want to. The old books that I've taught out of, they only give you two sides. And unless you do, and it's usually not a triple, unless you do Pythagorean's theorem, then you only have one option. And so let's say we didn't have this side and we didn't have to find this side and we were just looking for the measure of angle A, which trig function would we use? If we didn't have this side and we didn't want to find this side and we didn't have to find that side and we just had to find the measure of angle A, which trig function would we use? Sine. Because we have opposite and hypotenuse. But since we have to find any missing measure, we can use anything that we want to. So let's use tangent. Tangent of angle A is equal to opposite over adjacent. So to get rid of tangent, I have to do tangent inverse of the other side. So really, you can just slide that over and change it to inverse instead of having to show that you're taking the inverse of both sides. That's really what you're doing. So inverse tangent of 24 divided by 7 is 73.7. And then if I want to find the measure of angle C, I take 90 and I subtract 73.7 and get, is it 26.3? Let's just say, so this is all you have to show. You don't have to add anything else to your notes. You don't want to confuse yourself later whenever you're working the problems. But I'm going to show you how it wouldn't matter which one you choose. Let's say we, instead of tangent of angle A, we used sine of angle A. Sine of angle A is 24 over 25. So angle A is equal to sine inverse of 24 over 25. Thank you. That's what I get for trying to do a decimal. 80, 90, yep. Okay. So now let's just see if we get the same answer. Look at what we're doing. We're using different trig functions to find A. I'm just showing you how you have a choice here. Inverse sine of 24 divided by 25. 73.7. Okay, let's try cosine. So what would the ratio for cosine be for angle A? Cosine of angle A is equal to adjacent over hypotenuse. So inverse cosine of 7 divided by 25 is 73.7. So it's a matter of which one do you want to use and what are the sides that you use for your ratios. Okay? That you have it in here. Okay, so this is not something you have to do. I'm going to erase it. You don't have to do all of that work. This is all it takes to solve that triangle. I erased my angle there.
What are the, we need to show,
This is the least amount of work you need to show. That would be the simplest way to find those measures. So it's either this or more, depending on, you can use trig to find the other angle if you'd rather do that than subtract it from 90. Maybe you forgot and didn't know, do you subtract it from 90 or 180, so you might want to check your work by using trig on that angle. You can do that. And if you don't know your triples, you can use the Pythagorean theorem. And if you do that, just realize you're going to run out of time on your test if you're being tested. Okay, so we have an angle, we have the hypotenuse, we need to find x, y, and the measure of angle y. This is a right triangle, my 90-degree, or my right angle symbol's missing. Let's first look for x. We can find y very easily, this angle, because we know it's 90 minus 41. But before we do that, let's just focus on the angle that we have and the side that we have to find x. So we know we need x, we need y, we need the measure of angle y. That's an uppercase y, this is lowercase. So first let's find x. X, well, we have to use this angle and this hypotenuse to find x. What trig function involves this angle, this side, and this side? Okay. So sine of the angle is equal to opposite over hypotenuse. And to get x by itself, you would multiply both sides by 18.4. And if you multiply this side by 18.4, it ends up in front of sine. So x is equal to 18.4 sine of 41. .1. Okay. You have a couple of choices to find y. I would probably stick with using the same angle. And using trig instead. I'd rather do that than using Pythagorean's theorem, but you can use that here. It's up to you. So this would be cosine of the angle, because it's the adjacent side and the hypotenuse side. And it's y over 18.4. So y is equal to 18.4 cosine 41. So it's the same thing except for cosine instead of sine, because it's the adjacent side instead of the opposite side. And that's 13.9. And then to find angle y, that's 90 minus 41, which is 49. So you really had, your most options were here for the other angle. I mean, for the other side, side Y. You could use Pythagorean theorem, or you could find this angle and use sine if you want to, or you could use tangent. You could use any trig function once you have those angles up there. Any questions? Okay, here's your assignment, and you need to work on that until the bell rings, and I'll come around and help you if you need help.